and subtract. Same sign, keep the sign different, keep the larger.
Hello and welcome to the Kearney Math Show. Thank you all for tuning in today. On today's episode of the Kearney Math Show, we are going to be featuring adding integers. So before we get started, go ahead and write your name at the top of your paper and write entry number 2. So this is entry number 3. So write entry number 3 at the top of your mini lesson, E3. All right, so take just a second to read your learning goals so we know what we are expected to be able to do by the end of the lesson. So what we'd like you to be able to do is be able to create some zero pairs, which you guys have already done a little bit last week. We're going to be using the chip model like we used last week, and then also using the number line method. And then by the end of today, I want us to be able to come up with some rules in order to solve these problems without having to use chips and a number line, okay? So just to remind you, my expectations, as Ms. Kearney is going through the notes and as you're watching the video, my expectation is everything I write down on the notes, you are also writing down on your notes. If you have a question, then you can always pause the video, write down your question so that you can ask me later. So everything I write down, you are also writing down. Okay, so let's just start off by just refreshing our memory. What in the world did we say an integer was? An integer is the set of what type of numbers? It is the set of whole numbers, okay? And their opposites. So what did we say whole numbers were? Something like a whole number other than a decimal or a fraction. So the set of whole numbers and their opposites. For example, -3, -2, -1, 0, 1, 2, 3. And we could keep going in those directions. So integers are the whole numbers and their opposites. So what in the world did we say? What are opposites? What do we say opposites were? Opposites are numbers that are the same distance from where? From 0 on a number line, but on opposite sides of 0. So what is the opposite of -5? Positive 5. What's the opposite of 12? -12. Okay, so those are opposites because they're the same distance from 0, but on opposite sides of 0. Okay, then we're going to get down here to this really fancy word, an additive inverse. And if I can tell you a secret, guys, additive inverse is actually, let me say it quiet so no one hears me. Additive inverse is actually the same thing as an opposite. Do you hear that? Additive inverse is the same thing as an opposite. So the reason why it's called an additive inverse is additive inverses are two numbers when added together, add to 0. So two numbers that add to 0. AKA, we're going to put AKA for also known as opposites. Okay, so what's the additive inverse of 4? What can I add to 4 that would give me 0? -4. Okay, what's the additive inverse of -20? What can I add to -20 to give me 0? +20. Awesome. Okay, so moving right along. So we know integer is a whole number, opposites are the same distance from 0, and additive inverses are the same thing as an opposite. Okay, so let's just come down here and remember what we said last week about using chips to model this, and I'm going to show you how to use a number line. So I'm going to start on this example here. 4 plus -6. So if we were to start with adding chips, how would we model +4? We have 4 positives. And then how would I show -6? So I would come here and I'd add -6. And then we talked about 0 pairs last week. So do you see some that are 0 pairs? Yeah, this makes 0, this makes 0, this makes 0, this makes 0. So what are you left with? When you add those two together, you're left with 2 red, which is -2. Okay? So we can also use a number line to model the same exact problem. Okay? So the way you use a number line is you start on the number at the beginning of the problem. So we're starting on +4. So we're going to come over here and we're going to put a dot here on 4, +4. And it says we're adding -6. So since we're adding -6, which direction do you think we're going to get? We are going to go to the left, so the negative direction. So we're going to go over 1, 2, 3, 4, 5, 6. And where do I end up? At -2. Because when I go down, I've got to go past 0 to get to -2. Okay? So 4 plus -6 is -2. Okay? Next one. -4 plus +6. So picture this. Do you think you're going to have more reds or more yellows? We're going to have more yellows. So what do you think your answer is going to be? Do you think your answer is going to be positive or negative? Probably positive. So let's see. So we're going to start with -4. So 1, 2, 3, 4. And then we're going to add 6 positive. So we're going to add 6 yellow. And then when we mark out our 0 pairs, we're left with 2 yellows, so +2, which is what we thought. We thought we'd have 2 more yellows than we had reds, so we're going to end up with +2. So to show that on a number line, we're going to go down here to -4. Start on -4, and it says we're adding 6, adding +6. So which direction am I going to go? I'm going to go in the positive direction, so I'm going to go up 6. So if you notice, when I go 1, 2, 3, 4, 5, 6, you see I went past 0. So now I'm landing on +2. Okay? So when you look at a problem, ask yourself, are there more reds or more yellows? And what would my answer be? So for example, if you look up here at the top, I have red plus red. So red and more red. So what do you think your answer is going to be? Red, which is negative. Okay? If you look at the next one, 6 and -10, what do you have more of? Red or yellow? You have more red, so your answer is going to end up being red, which is negative. Okay? So I'd like for you to take a minute. You're going to have a chance during class today to look at more of these practice problems and do some more. But right now I need you to flip over, not you, but your paper. And I want you to look at the back where we have this little chart. And I want you to help me figure out, okay? Right now, I love using chips and I love using a number line. But if I give you the problem -100 plus 75, would anybody really want to have to write out 100 chips and 75 chips? Probably not. Would you even want to have to go on a number line and go all the way down to 100 and then go up 75? Probably not. So chips and number lines are very helpful. However, we can't always use them because we don't always want to have to draw out chips or use a number line. So we've got to find a more efficient way to solve the problems. So what I want you to do is I want you to help me find a pattern and help me figure out what the rule could be so we don't always have to use chips in a number line. So I'm going to show you some problems, okay? I want you to consider the following problems. -2 plus -4 would be -6. And -5 plus -3 would be -8. And -3 plus -8 would be -11. -7 plus -5 would be -12. Okay? What do you notice all of these problems have in common? What's something they have in common? Do you notice that they're all negatives? So a negative plus a negative, and we're getting another negative. Okay, so all of these, we're having the signs are the same. You see that? Same signs. Okay, now I want you to look. I want you to see what is the pattern, what's the relationship that you see between this number and this number and the answer. So we've got 2, 4, then we get 6. Look below it. 5, 3. We look over here and we get -8. Okay? -3, -8, and we get -11. What's the pattern? What are you doing? So we have -7, -5, and we get -12. Do you see what you're doing with those two numbers in order to get your answer? So what do you do with 2 and 4 to get 6? You're adding them. What are you doing with the 5 and the 3 to get the 8? You're adding them, okay? So if the signs are the same, if they're both negative, so same signs, and just like in the video, you heard same signs, add. So what we're going to do if the signs are the same, if they're both negative or both positive, you're going to add, okay? And then if you're adding red and more red, what's your answer going to be? Red. If you're adding yellow and more yellow, what's your answer going to be? Yellow. So basically, your sign is going to stay the same. So same signs add, and then you're going to keep the sign. Okay? So same signs add, and then I want you to look at this. Here's my next pattern I need help with. So what if the signs are different? So -3 plus 7, and that gives me 4. 6 plus -4, and that gives me 2. And -10 plus 3, and that gives me -7. Okay? And then we'll do one more just for fun. -4 plus 10, and that gives me -4. Okay? What do you notice that all these problems have in common? Are their signs all the same? No. Their signs are different. We've got a negative and a positive, positive, negative, and a negative and a positive, a negative and a positive. So the signs are different. So now let's see if there's a pattern. What are you doing with these two numbers to get to this? What can you do with 7 and 3 to get to 4? We can subtract 7 minus 3 and we get 4. What can you do with 6 and 4 to get to 2? We can subtract. What can you do with 10 and 3 to get to 7? We can subtract. What can you do with 14 and 10 to get to 4? You can subtract. So we just said a second ago, if the signs are the same, we're going to add. So what do you think we're going to do if the signs are different? That's right, we're going to subtract. So same signs add, different signs, you're going to subtract. Okay, and then how do you know if your answer is going to be positive or negative? So I want you to look up here. The first problem, was there more red or more yellow? There was more yellow, so our answer would be positive. Number 2, was there more yellow chips or more red chips? More yellow, so our answer would be positive. This one, are there more yellow or more red? More red, so my answer is going to be positive. Okay? So basically what you're going to do, and I'll explain this, you're going to see this a little more when you come to do more practice, but you're going to keep the one that has more. So if there's more negative, your answer is going to be negative. If there's more positive, your answer is going to be positive. So the way we say that is you're going to keep the sign of the larger absolute value. So the one with greater absolute value. So which ones? So for example, 3 and 7, 7 absolute value is bigger than 3 absolute value. So my answer is going to be positive. Okay? So just to recap, same signs add, different signs subtract. Okay, and just to do one practice problem. Right down here. Number 4, what do you notice? Are the signs the same or are they different? They're the same, so I know I'm going to come up here, same signs add. So 20 and 30 is 50. And if it's red plus red, I'm going to have all red. So I'm going to keep the sign, which is negative. Okay? So this is going to help you to be able to solve these problems a little quicker without having to use chips and number lines. So just to recap, same signs add, different signs subtract. All right, guys, good job. If you will, take a moment. You can always go back and rewatch the video, or if you can go ahead and you may start on some of the practice problems and go back to the front and you can work through some of those integer chip models and number line models. And I'll be happy to answer any questions that you have. All right, good job, guys. Make me proud. Peace out, Rainbow Trout. Love ya, mean it.